Alright, so I'm going to continue on here talking about the usefulness of standard deviations and how we use them to compare data values from different data sets. So I skipped over standard deviations, and I have some links below here from Khan Academy, and please check those out before you continue any farther if you haven't already. They'll also be posted to the course website. But that's one of the things that he does a great job of teaching, and I highly encourage you to look at that first. But yeah, so once we understand that a standard deviation is a measure of the dispersion of data, we can kind of start to evaluate the data a little farther and start to compare different data sets, which is getting more and more towards that inferential statistic piece. So the formula that they use here is the number of standard deviations is equal to the value minus the mean over the standard deviation. So this value is each individual value. So if I'm looking at a sample, it's going to be that sample mean minus the mean over the standard deviation. And that's, that value really could stand for a lot of things depending on what the question asks. What that number of standard deviations is called, it's called a z-score. We can use the symbol z to describe this, and it is important, though, that you understand that z can be for a sample or for a population. And as described in the Khan Academy videos, it is important that we use the correct standard deviation if we're talking about samples or populations, because they do vary. Because if you have a sample, you have to add a little margin for error. So x bar here is the mean of the sample, and mu is used as the correct population parameter. So x is a statistic, x bar is a statistic, mu is a parameter. Similarly, s corresponds with the standard deviation for the sample, and sigma is the same for the population. So this gives us what's called a z-score. It kind of seems a little ambiguous now, and I understand that, but it is really useful for it's almost like putting things into a common unit. So I know standard deviations for any set of data across any units that they are representing. So I can look at data for income in dollars and think of it in terms of z-scores and think of how that data is dispersed and completely compare it to the dispersion of data in a very different unit, say hours worked or something. Those might have very similar z-scores because they're similar, they're correlated, but it kind of gives you an idea of putting things into a common unit. And we'll get there a little bit. I'll go on a little bit more about that. So if you wanted to compare US dollars to Canadian dollars, you would divide by US dollars per Canadian dollars. And here we're going to divide by the standard deviation. So it's just a way of putting things in common units so that we can better compare them. And sorry, those were actually out of order. But let's go to this example here. So we have two students, John and Allie, from different high schools who wanted to find out who had the highest GPA when compared to his school. Which student had the highest GPA when compared to his school? Now, this is what I mean in using a common unit. So we don't know how the GPA for, I assume John has a GPA on a scale going to 4, which is really common. The other GPA, I have no idea. Another good example would be ACT and SAT. We want to be able to compare them even though they're in very different units. So we go ahead with this process of that equation above, and we say z is equal to the number of standard deviations, which is equal to the value minus the mean over the standard deviation. For John, z is equal to 2.85, which is his GPA, minus 3, which is the GPA of the mean GPA of his school, over the standard deviation of his school, and that's negative 0.21. Similarly for Allie, you're going to take her individual observation value, which is 77, minus 80, which is the mean of the school, the mean GPA of the school, divided by 10, which is the standard deviations. And you're going to end up with negative 0.3. Those are negative 0.21 standard deviations and negative 0.3 standard deviations. That tells us that John has the better GPA when compared to his school because his GPA is 0.21 below the school's mean, and Allie's is 0.3 below. So think of, on a number line, you're going 0.2 to the left versus 0.3 to the left.